Hi everyone, I'm Nathan, aka Cynic. Welcome to the channel. Today we're diving into an exciting project on security orchestration, automation, and response solutions, otherwise known as SOAR. Many security operation centers are implementing SOAR solutions to reduce repetitive tasks through automation while following structured processes, known as playbooks. Without an experienced individual developing and improving these playbooks, SOAR can become just another expensive tool. So I'll provide you with an automation project using Tines as the SOAR platform. We'll also use LimaCharlie as our EDR, Endpoint Detection and Response, and a Windows VM in the cloud as an agent. You do not need to spin up a cloud VM. Any Windows machine with internet connectivity will do. If you're worried about coding, don't be. We have ChatGPT and documentation from both Tines and LimaCharlie to guide us. By the end of this video, you'll gain hands-on experience with both an EDR and SOAR platform, which will be valuable for your professional career. Let's jump right into it. In part 1, we'll focus on creating our playbook workflow and brainstorming the actions we want our playbook to take. Building out a workflow helps organize thoughts and see the steps needed to accomplish our objective. Our objective is to send a Slack message and an email with important information about the detection that LimaCharlie generates. Tines will then prompt the user to isolate the machine, and if the user agrees, LimaCharlie will automatically isolate the machine. To create a workflow, I'll use draw.io, a free and quick access tool. The workflow doesn't need to be pretty, the focus should be on functionality. So, as we can see here, I have already created my workflow. LimaCharlie detects a tool and sends the detection to Tines. Tines sends the message with details to Slack and an email. Tines prompts the user to isolate the machine. If the user selects yes, LimaCharlie isolates the machine and sends a Slack message with the isolation status. If the user selects no, a Slack message indicates that the machine was not isolated and advises investigation. Using various icons to represent each step, the workflow includes details such as time, computer name, source IP, process command line, file path, sensor ID, and a link to the detection if applicable. In this section, our objective is to install and set up LimaCharlie and make sure that the endpoint is connected and generating events. By the end of this section, you should have one Windows machine reporting back to LimaCharlie. Then we can begin creating our first detection and response rule. I'll be using Vultr as the cloud provider and we'll be spinning up a Windows server machine. If you want to follow along, I'll leave a link down below for those who want to use Vultr. For those of you who don't know what LimaCharlie is, a quick overview is that they are a security operations cloud platform that offers a unified platform where you can build customized solutions effortlessly with open APIs, central telemetry, and automated detection and response. LimaCharlie is pretty powerful if you know how to use it, and lucky for you, this project allows you to gain some hands-on experience. We're going to go ahead and set up our firewall group. To do that, go ahead and click Add Firewall Group. And right now it's accepting SSH from anywhere that we do not want. Instead, we will select MSRP, which is Microsoft Remote Desktop Protocol on port 3389. Where do you want it coming from? Currently it's set to anywhere. I'll select my IP and then make sure you select the plus button to add the firewall rule. Once that's done, head back over to our virtual machine and then we can add in our firewall. To do that, we can select settings, and on the left you want to select firewall. Right now we see no firewall. Select EDR firewall, click on update firewall group. Now we can go ahead and test it out and RDP into our server machine. Once the organization is set up, we'll create an installation key and download the LimaCharlie sensor. We'll install this sensor on our Windows machine and register it using the installation key. With the sensor installed and registered, the machine will start reporting to LimaCharlie. We'll briefly explore LimaCharlie's interface, focusing on sensors, detections, and outputs, which will be essential for our project. Finally, we'll verify the sensor is active in LimaCharlie. Right here we have auto runs as well. So this is a list of all the auto runs on the operating system. If you're familiar with persistence, this is essentially where you'll look to identify persistence. Going over to console, this is where you can run remote commands from LimaCharlie. Netstat, perfect. So there you go. We have our netstat output. It also includes the process ID, so you can identify suspicious processes. You can look at the netstat output to see if it's establishing any outbound connections towards a suspicious external IP address and so on. Detections, so there's no detections right now. You can look to see if there's any suspicious drivers here, and we're looking at event collection, so all these events being collected from the server. Then we have file system. It's an awesome option to have because let's just say that a malware exists. We'll click on desktop, and I know we do see desktop.ini. Let's just pretend this is a malicious executable. We can inspect the file hash, for example, and use VirusTotal if we wanted to. Or we can download the file if we want to do some malware analysis, so on and so forth, or even delete the file. If we go over to processes, we get a listing of all the active processes that are currently on our server, and what we can do as well is click on it and we can kill the process, view the module, suspend it, resume, download the memory strings, which is amazing, and view memory map. What I like about this is that you can also see the command line. Imagine if someone calls you up and they say, hey, my computer is running pretty slow and my mouse is moving by itself. Now you might be like, okay, we might have something interesting here, like Excel spawning a PowerShell script running with encoded commands, so that is likely something very strange. Then you can pivot over to network to see if there's any network connections that were initiated by that PowerShell encoded process. What you can also do is pivot to auto runs and see if there was any persistence created by that PowerShell, any services installed that are running. There's also a timeline analysis, which is incredibly important. So let's just say a user calls you up at a certain time and says, hey, something strange is on my computer. Well, we can take a look at the timeline and see the surrounding events very quickly. If you do find something interesting, just click on it and you can get all the details right away. And lastly, we have our users, so we can see the users that exist on our server. Going back over that PowerShell example, maybe that PowerShell created a new user afterwards, who knows? But you can see that user here, and you can also see when they logged in on the machine as well with LimaCharlie installed. In this section, we'll generate telemetry using LaZagne, a password recovery tool, and create a detection and response rule in LimaCharlie. Head over to LaZagne's GitHub download the executable, and disable Windows Security by searching Windows Security. Select Virus Threat and Protection and disable Real-Time Protection. Then download LaZagne, bypassing any security warnings. Now we can open PowerShell in the download directory and run LaZagne to ensure it works. Check if LimaCharlie picks up the LaZagne process. Go to the sensor list, select the sensor, and view the timeline for the new process event. Open a new tab for LimaCharlie, go to Automation, and create a new detection and response rule. We can go ahead and use an existing rule, and we do know that LaZagne is a credential access tool. Here's what we're most interested in. It's the process creation. Take a look at the event type. It is set to new process, so these are all process creations. We do see a Windows process creation, and at the bottom we do see the content of this rule and the GitHub repository, so I'll click on that there. You go, here's the rule right here, click on raw, copy, and head back to our rule and click the pencil icon. Now we can go ahead and paste in what we just copied. Now if you take a look at the top, we do see a detect, we do see a respond. So this essentially signifies the two blocks here starting from respond. I'll just select all this and cut it, and then I'll paste it inside the respond block. Now we don't actually need the respond here, so I'll just go ahead and remove it. Remember that respond is just telling us that, hey, this is the response portion. Similar to detect, we don't need it. We'll remove it and expand this. There you go. Starting from the beginning, we do see events with new process and existing processes. So what does that mean? We want to select event collection, and from here is just simply grabbing these event types. So if I search up processes, we see existing processes, and if we scroll down we also see new processes. So this section is essentially saying this detection will only trigger if the event is under the new process or existing process event type. Now we get our first operator, and this operator of AND. So what does that mean? Well, it means the event type must be either new process or existing process, and the AND is specified by this operator. To get a list of operators, they actually provide some right here. So operator reference. So let's go ahead and remove this, and then let's continue on. And rules is going to be the criteria, so meaning you must follow these rules. The operator is Windows, case sensitive is false, and the next operator is ends with. The path is event/file path. Heading back over to our sensor, let's go back to our timeline and search for our LaZagne process. Clicking on the new process because we're interested in the new or existing process. So I'll click on that, and we do see a file path here. That is why we have an event and event file path. For example, let's just say I'm interested in the hash. Then what we'll do is I'll type in the event/hash. So I'll keep this as a file path where the value ends in device credential deployment.exe. So let's bring back to plain English here. What the heck does this mean? Well, essentially it is the event type must be either the new process or existing process. It must be a Windows machine. We can ignore case sensitivity, and the file path must end with device credential deployment.exe. Now if we wanted to detect our process of LaZagne, we can simply replace device credential deployment with LaZagne, and in theory that should technically work, so let's go ahead and do that. Now if we take a look at our events, we can see that the file path ends with LaZagne here, but notice how the Z is capitalized. That is why we have the case sensitive as false. So regardless, even if our value has a lowercase z, or in this case a capital Z, we should still be okay. So I'll keep this as that, but let's go ahead and add some more options, because if you recall, let me head back over to my server here. Take a look at the different flags that are available for LaZagne. We have browsers, chats, databases, games, Git, Mills, Maven, memory, multimedia, and more. So let's just say we got a password like so. Now let's go ahead and head back to LimaCharlie. I'll save this for now. Let's go over here and we'll refresh this and we'll wait a bit until the process is generated. So after a couple of seconds, we do get our new process that occurred, and I'll click on this one here. So yeah, taking a look at our file path, we do see lasagne.exe at the end. But if you take a look at the command line here, we do see an all this time. If we look at a previous process for the command line, we just see it as lasagne.exe. We don't see any command line arguments associated with it. Now let's add on to our detection rule to include this command line argument. So the new rule that I want to create is that the event type must be either new process or existing process, and it must be Windows, and the file path ends with lasagne.exe, or the command line ends with all, or the command line contains lasagne, or hash equals the lasagne hash. Now, I do foresee some false positives for the command line that ends with all. I mean, for example, we have an ipconfig/all that's going to trigger that, but for this demo, let's just keep it as is and we can build it out. Currently, we have this section good. Now for this next section, I'm going to fast forward this part. We're just going to continue refining the rule, ensuring it includes necessary criteria like command line arguments and file path. And then we will go ahead and test the rule out with sample events to ensure it detects lasagne correctly. And after refreshing the detections, we do see a couple detections here at the very bottom. Right here we can see the hack tool. Here's our event. We have our command line, lasagne, all. We have the file path. We got the hash. We got our host name, the external IP address. So we can use this information here for our playbook or story when we build it in Tines. So for this section, we're going to be setting up Slack and Tines to test connections between LimaCharlie and Tines for a SOAR EDR project. First, set up Slack workspace and create an alerts channel. Then create a Tines account and explore some playbook options. Take a look around. Then we're going to start establishing a connection between LimaCharlie and Tines using a webhook. Next step is to confirm detection visibility in Tines for automation. Now, this is important because we are utilizing Slack and Tines channels, and that improves organization and focus for handling alerts efficiently. To use webhooks, that enables seamless integration between LimaCharlie and Tines for data transfer. Then we can have some confirmation of detection visibility in Tines that ensures the effectiveness of the SOAR system in detecting threats. For this next section, we're going to be building a workflow to send messages to Slack and emails based on detection rules. Then we'll be establishing a link between Tines and Slack for communication. The next step would be to create a playbook to prompt user isolation decisions and automate machine isolation. Then we can start testing and verifying the workflow steps for successful execution. Now that we're using LimaCharlie to isolate machines based on detection alerts, we can send status messages to Slack confirming machine isolation. This video walks you through the process of building a comprehensive security automation project, emphasizing the importance of setting up workflows and linking tools effectively. By establishing connections between Tines, LimaCharlie, and Slack, the video showcases how different security tools can work together seamlessly to enhance incident response capabilities. The creation of a playbook to prompt user decisions and automate machine isolation highlights the power of automation in streamlining security operations and response procedures. Through testing and verification, as you can see here, each step of the workflow has been working, and now we can emphasize the significance of thorough testing to ensure the successful execution of automated security processes. The integration of LimaCharlie for machine isolation based on detection alerts demonstrates the practical application of security automation tools in real-world scenarios. Sending status messages to Slack to confirm machine isolation showcases the importance of clear communication and reporting and incident response processes. Overall, the video provides a comprehensive overview of setting up, testing, and utilizing these tools to enhance cybersecurity incident response capabilities. As you can see here in our server, when the playbook has been initiated and the user selects yes to isolate the machine, every response to ping google.com, for example, is being denied. So we can know that our work has been successful.